Hi folks, this is lesson 6b, the computing model second part. And even this second part has three subsections, somewhat distinct. First subsection is an overall study of cloud computing, mainly from Gartner, from different points of view, and these are all reasonably recent. The second study these are all relatively recent. Second study is cloud market share, comparing the battle between Microsoft, Amazon, etc. And finally, we have some discussion about the hottest topic in the world, almost blockchain, which is really revolutionizing enterprise work. So we have these three things: blockchain, cloud market share, and the cloud computing model. And let's go. Thank you. All right, here we have the first part of lesson 6b, which is study that actually was done I did in 2017, so it's about a year old now, but it's still up to date till a year ago, of aspects of cloud computing and the cloud computing model, mainly again coming from Gartner, which has these excellent studies. Okay, let's get started. Thank you. This is, of course, the Big Data Application Analytics course. All right, hype cycle for cloud computing. And Gartner has hype cycles running everything. And you can see that this hype cycle is not so easy to interpret because it has, whereas the main hype cycle for emerging technology is full of broad concepts, this is full of pretty detailed things such as, I don't know, API economy. I'm not quite certain what that is. Container management is a pretty solid, straightforward subject. I don't know that I get excited about it. It's pretty important. IoT platform, that's a non-trivial area because of the importance of edge computing. Hybrid cloud computing, we've actually sort of looked at that already. Serverless platforms, that's pretty interesting. That's something we'll discuss a little later on. And software-defined anything is also important. That's what you need to have to be able to do software-defined systems. Cloud Office is presumably Google Docs and Microsoft Office 365. Cloud bursting is how you go from private to public resources. Private cloud computing we've mentioned. Platform as a service. Infrastructure as a service. Software as a service. These are the basic ways the clouds can be offered, quite wide, or in that order of maturity, I'm not certain. Virtualization. That's what clouds are built, and I would not consider it that mature. It's OpenStack, the one we typically use, is pretty flaky. All right, notice this comes from Sweden. There was a talk by somebody from Gartner in a Swedish conference, and this was his slides. Notice these hype cycles are all sold in separate documents, each of which costs $1,995, so it's not something you're likely to buy. So you browse the web and hope to pick them up. All right, so here we have the trends that this speaker from Gartner identified, going with that chart, that it says here you basically have to use clouds, otherwise you're going to fall behind the competition. You can't just wait any longer. You must plunge in and use the public cloud. No cloud policy or no internet policy are both incorrect today and will be more obviously incorrect in 2020. By 2019, 30% of the new software will have shifted to cloud only. They're not just cloud first, they're cloud only. For trivial reasons, you don't really want it to support multiple deployments. Half of the applications running in the public cloud will be mission critical. So that's pretty interesting. The clouds will be essential. That's by 2018. And by 2020, clouds will be the dominant expenditure area compared to mainstream. I know when I began working in this area, 2008 or something, that wasn't obvious. That was pretty controversial. And I like this one. 2020, only 5% of the cloud security failures will be due to the cloud. The rest will be your vice president for important things leaving his laptop on the bus or something. All right. All right, here we have 3 magic quadrants. We've seen this type of thing before from Gartner. They have challengers, leaders, ability to execute. Here we have niche players in the bottom quadrant and visionaries who are pretty good along the completeness of vision, but not really so complete as to be competitive in execution with the leaders. And we don't actually see any challengers in any of these quadrants. We see Amazon sitting at the top here, and we see Microsoft actually increasing each year. And we all see that in other graphs as well. Microsoft is doing pretty well. Google is slightly increasing, but not really as fast as Amazon. And we have Rackspace sitting in here, which is, we quite like Rackspace because they sort of invented OpenStack, so they're well known because of that. And here's VMware. So these are VMware offers a much more specialized service than the others, so it's put down there. It's doing pretty well as a company. It's just not a complete cloud infrastructure as a service company in the same way as Amazon or Microsoft or Google is. So this also comes from this talk in Sweden where this Gartner employee gave a keynote of some sort. Okay, that's it. We go on to the 2017 version of this in the next slide. And it's now become a computing magic circle, not a quadrant, but I think it's still a quadrant. And this is a better resolution. Amazon's still up the top. Microsoft, no better than it was in 2016. This is pretty recent, June 2017. Here's Google. It's almost crossing the line. And then back here, we have Alibaba, obviously a major Chinese vendor. China will presumably have Chinese clouds. IBM, Oracle, and Rackspace. It was the people who developed OpenStack originally, and I must admit I'm not familiar with the others. But they're still niche players, so we needn't probably worry about them too much. So we have already a 3 to 5 horse race. Let's add Alibaba and IBM as horses of relevance. Here we have just 4 of the horses with market share in 2016, and Amazon is clearly more than all the others combined, 31% of the total. Here is Gartner's list of how they form the magic quadrants or magic circles. They look at these capabilities, compute resilience, architectural flexibility. Do you have GPUs or not? Or do you have large memory or small memory? What about all your security and your way you manage your users? Way you integrate with enterprise systems? How about DevOps? Do you support Ansible, Chef, Puppet, etc.? Scaling, how elastic is it? And how does big data run on your system? Do you have great NoSQL databases like Dynamo and things like that? Use cases, how the various things needed for use cases are supported. Cloud native means that the application runs well on clouds. There are various articles around which tell you how to build cloud native applications. Then we have general business applications, in edge computing, the Internet of Things, batch computing, that's sort of solid, dominant, need, as well as the opposite to batch is real-time or streaming computing, and we need to be able to develop our applications. Here is a graph from some rather, well, no, maybe not so interesting discussion of how you decide what clouds you need. Here and this moves up here from the bottom, where it's really at the very low level IT tasks. Here are the IT services, and here are the business services, where all the business services where your applications lie. And they're just recommending that you need to work back from what you want to do to what you need in these bottom layers here. And here we have provisioning, patching, configuration, and compliance and audit. So there is a document which describes this in detail. Comes from Gartner. Okay, this comes from the 2017 Internet Trends report by Mary Meeker. A lot of my slides come from that. And here we have the total IT infrastructure spend, and this tells you the fraction of private, public, and traditional. And not surprisingly, given the focus of this class and the way the world is going, the amount of public and private clouds is growing. It was 23% total in 2013. It is 37%. It's a very significant increase in 2016. This number here we'll see on the next curve corresponds to about $36 billion. So obviously, public and private clouds will overtake traditional data centers, not so far in the future. All right, here we have some actual numbers. The total cloud IT infrastructure, again divided between public and private, with again the public about 50% more than the private, so maybe the private is 40% of the total cloud, and the public is 60%, solid 13% annual growth. And here we're up near 60 billion for the total cloud infrastructure, which is again divided, as I said, roughly 60-40 public to private. Here we have a particular subset of the cloud market, infrastructure as a service, and we see here a strong growth, 38%. Remember the previous one was 13%, and we're up to 22 billion for infrastructure as a service in 2016. Remember the total was 38 billion for all of clouds in 2016 from the previous slide. So infrastructure as a service, which is a little surprising because it's the lowest level where the user has to do most, is growing the fastest. That's because probably some of these things like software as a service are not done very well and are a bit clunky, and infrastructure as a service allows you to do it better. Here's the strategy. I mentioned this number, the public to private was 6-4, but here in 2016 is private, that is this 30%, hybrid 23%, and public 47%. If you divide the 23% equally between public and private, which sounds reasonable, you will get roughly the 60-40 public to private ratio I quoted earlier. Remember, hybrid is private on the premises of your enterprise data center, going out to the public, so-called bursting out of the public for additional capability. All right, let's go. Here we are. I'm having trouble with this slide in quite understanding. I don't think it's quite consistent with some of the other slides. Here's 2014, and we have 36% traditional IT, but 45% private cloud, which seems very high to me because previous slides had lower amounts of private clouds. Here we have 19% public cloud, and that 19% is growing to 48% public cloud in 2019, and with traditional IT being 40% and private cloud being 38%. I think this slide is using a different decomposition between private and traditional IT, cloud and traditional IT, both of which are private systems than previous charts we had. I don't. So let's at least focus on this: 19% public cloud, going up to 48%. That's a pretty solid number. So here is an interesting plot telling us about in 2016 and 2017 where people are running. That's the blue things in 2016 and green in 2017, and this graph here compares 2016 to 2017, showing Amazon maintains a constant usage. Microsoft, which is Azure, is growing very significantly. Is growing actually more than Google, and is certainly a lot more than IBM. So it says Amazon is hanging in there, but Microsoft is doing very well, very aggressive. Even though they start off with the disadvantage of running Windows, they now have adopted Linux properly, and so they're actually very competitive with the other people. They have a very rich infrastructure. This one here is only in 2017, and it tells you about what they're running, which is the same as this thing here. Well, actually, this blue thing is the same as the green thing here, because this is the running applications, which is in 2017, which is the green ones over here. And then we have experimenting, planning to use. And we can see it's actually interesting that Google has the most people planning to use it, and IBM is the lowest, but Google is almost the same as Microsoft and not really that far ahead of Amazon. But Amazon and Google both have 70% experimentation and Microsoft 21%. So this says that you can expect IBM to increase, Amazon, in fact, to decrease probably, and Microsoft to go up quite a bit, and Google to go up probably a little. Pretty interesting. Okay, so this is a sort of more cosmic picture with some graphics telling you what the core ideas are. There are things like serverless computing, which are new ways of delivering software in all sorts of different ways, with software-defined systems and Share from Puppet and Ansible and things like that. Then we have containers, and we have microservices, which are instantiated in containers to simplify the software deployment. Then we have wonderful analytic databases, and namely a database like BigQuery attached to an analytical engine. And those are really quite important, and they have elastic bands because they can be expanded. And then we have a major driver for cloud computing, edge computing, which pushes the computing to the edge. But more importantly, the data source is the edge, and that data will sometimes get processed on the edge, but also go back to the cloud. So cloud support to the edge is take the data where needed from the edge, which is sometimes processed data, and decide what processing to do on the edge and what processing to do on the cloud, and make that relatively seamless. For example, Amazon has a system called Greengrass on the edge, which is the same as Amazon Lambda, which is their elegant event-driven system on the cloud. And Lambda's on the cloud, Greengrass is on the edge, and they're same or similar API. This is just a sort of an amusing plot of what was the ratio of designers to software engineers was in 2011 to what it is in 2017. 1 to 25 to 1 to 9. That's Atlassian, which is a well-known company supporting uh, software engineering. Dropbox, which has already quite a high number of designers to developers. IBM, dramatic reduction. Dramatic increase in the number of designers per developer. Same, it just seems to be a sort of universal number, somewhere between 1 on 5 to 1 in 10. And LinkedIn actually has always been pretty good with designers, and it hasn't changed so much, but it has got a little more focused on designers. All right, now we finally come to lesson 6B, which is actually pretty amusing. It's really amazing how much money is being spent on clouds. Tens of billions of dollars are being spent on cloud infrastructure every year. And part of this is clouds. So actually, maybe most of it is clouds that drive the internet companies, Facebook, Baidu, WeChat, Amazon, with their actual real business. But a lot of it is also public clouds, which are gaining more and more subscribers. It's a staggering development, and the scale is amazing. Let's see. Let's get some details on this. Okay, thank you. All right. So here is a nice pit representation of comparing the different cloud providers. This comes from the Synergy Research Group, and we find that Amazon is in a different class. It's way ahead in terms of market share. And Microsoft is actually gaining on Amazon, but still has a long way to go. Now, it is a little subtle here. You can get Microsoft to look bigger if you include Office 365. You can make Google to look bigger if you included all the services that run Google Sites, Gmail, And of course, Amazon would get bigger if you included their e-commerce machines as well. So anyway, here are the ones we saw before. Some in the previous Magic Quadrant of Gartner. This is not a Gartner slide. It's and here we have growth rate up here, and where we are here. And you can see that Microsoft, Google, Alibaba are technically growing the fastest, but Amazon is growing, but not so fast, and because it's so big that you can't grow so fast when you're so big. All right, pretty interesting. But this is perhaps even more interesting. This is money. All right, so these are revenues, amount of dollars Amazon gets from its web services division, AWS. And you can see that last quarter, Q317, well, if you're, let's say it's Q317, it may or may not be last, depending on whether where you're listening to it, when you're listening to it. And they got almost $4.5 billion per quarter, which if you think about it, probably corresponds for the next year. They're going to get at least 20 billion because it's increasing. All right, $20 billion a year. That's a pretty reasonable business, just AWS. And of course, it's larger than the others, as we said. This is a related slide showing a related effect. Here are the from Wikibon, which is another online website telling you useful things. And this one tells you how the various forms of enterprise computing change with time. Here we're sort of here, 2018. And here we have that maybe clouds are a third of the total at this stage here, and they're going to be 50% of the total somewhere. Well, they're certainly 50%. They're probably 50% here, 2026. And this is divided in various categories here. Some staff in the middle here, this purple thing. And notice that these ones here are going down. Operational IT staff in enterprise is declining 7% per year. So the job of working in enterprise is not a winning idea. However, if you want to go and work in a cloud vendor, that's growing 19% per year. So jobs are switching from the enterprise data centers to the cloud data centers. And the size of the enterprise operation is declining 3% per year, the traditional operation. And as I said, the clouds are going up 19%. So this is pretty interesting. And you can study this in detail and show the different components, how accurate they are. I don't know. And some of these separations are not so clearly interesting to me, but I think the message is clear. People are moving to the cloud. I think this difference is very interesting. 19% public clouds, minus 3% traditional enterprise. Remember that one. All right, so if you were a CIO and somebody surveyed you and you said, what's important to me? What am I worried about? Well, there are many things to worry about, but in this survey, 74% clouds were on their mind. And the next thing on their mind was the Internet of Things. How do I cope with all these things around my organization? Monitoring my equipment and my cars and my aircraft and actually even my people, because they're for the wearables, which are broadcasting everything to the world. And then AI is going, they should be more worried about AI because AI is going to have real importance to their organization. 3D printing, that's maybe now it's almost getting established. Virtual reality or augmented reality. And then back here is blockchain. That's pretty yummy technology. That's all about cryptocurrency and trusted distributed ledgers. Pretty important in this world. All right. Here's another variant of that graph where we had in the from Wikibon, from a different from IDC. And this has got the same 19% number, slightly different time interval actually, but well, average over year is still consistent. And it's going from 67 billion public clouds to 162 billion. And here you have, here's you can see again, in this one here, it's about equal in 2021. About 50% clouds, whether private or public, and 50% traditional IT. So no wonder Oracle is when SaaS and things are moving into the cloud market. They have to. The traditional market is going down. Okay. This is a well-known, amusing plot. It's been updated here to Q117, and in that quarter, remember that quarterly revenue is about 4 billion. It's no, a little less than 4 billion in that quarter. They had a profit of $890 million. So they actually got pretty healthy profit. Profit margins about maybe almost 30%, 20 to 30%. And what was the total profit of Amazon? Just one. So we find that the AWS is 89% of the operating income of Amazon. So it's not always that, but it's always pretty healthy. Here's a case where actually Amazon showed a profit, but without web services, it would have shown a deficit because the total here was less than the web services number. So AWS makes money. That means they can reduce their prices when Microsoft and Google put pressure on them. So Means you can negotiate a good deal if you think that, well, they're no good at science. Well, maybe they give science a deal because they are making money. Here's another look at this increase from 67 to 162, showing how it goes up per year. This again with this 19% number. All right, big data application analytics, folks. This is lesson 6B, third part, blockchain. The blockchain is a really, actually not a deep technology. It's been around in computer science for a long time, but it allows you to build very reliable, robust, secure ledgers. And so it's a very, and also which ledgers are distributed. That's the key point. And we have a set of slides on that which now follow. This is the last discussion of the computing model. Thank you. Oh, well, here's blockchain. So this is Gartner on blockchain. It doesn't actually explain what blockchain is, but we will come to that. It's a distributed ledger technology for basically robustly recording transactions and the associated certification trust and the associated digital currency associated with it. And it is distributed, collaborative, and it's a technology to which is pretty important because it allows one to do things, potentially allows one to do things in an automatic, robust fashion. And Bitcoin, which is an associated hyped thing, even more hyped, is the digital and the candidate digital currency for blockchain. And this allows untrusted people to collaboratively agree on something and to record it in a way that cannot be changed. We will describe this in a little more detail later on. And it's all very immature, very poorly understood, unproven, and it has not really been developed inside a traditional solid framework. Slightly surprising, given it's trying to do something pretty solid. But it's interesting that Gartner thinks that through 2018, 85% of projects with blockchain in their title won't actually use blockchain to do anything useful. They have an article on the Bitcoin, blockchain, magic, and myths. And there are lots of legal and regulatory and institutional issues, and how these are peer-to-peer, distributed peer-to-peer technology with an intrinsically linked list, which is difficult to change. That's why it's so robust. Okay, so the world needs ledgers because we have all these entities working with each other, and they sort of send messages back and forth, and it's pretty confusing and ad hoc and actually pretty insecure. And we even see that when we try to use our credit card. It's pretty flaky. I'm always getting fraud alerts on my credit card. Okay, so we set up a distributed record of all these transactions across these institutions in a way that it is basically impossible to change one thing without changing everything, which will cause disaster. And so this protects the whole system. The fact that it's got so many people, any one person is untrusted. Sorry, not untrusted. But if you have hundreds of untrusted people, then they sort of end up trusting each other because they can't all be conniving together to screw you. All right. So it's a append only. All you can do is append information to these records. So it's a ledger, which is append only. We have business terms embedded in the transactional databases. Everything is transactional, and it's privacy. They're verifiable. Transactions are authenticated, secure. But this whole technology is designed so it cannot be changed, and then you end up agreeing, because what else can you do? So here is actually Wikipedia's definition of blockchain. So it's just a list of records which can have branches, and you link them, and you have a hash to the next link, the link that you came from. So that's why you can go back. You have timestamps and you have data. So that's what it is. It's a very simple technology, and it's very difficult to change the data, because if you change the data, you ruin everything, because they're all linked together. It's a giant snake running through all these companies, and that snake cannot be changed. And so it's a verifiable permanent record. Typically, it's a distributed, because we have lots of distributed entities involved. You use peer-to-peer network technology, and the protocols are validating new blocks, and the data in the block can never be changed unless you change everything. And that requires collusion between everybody, because you can't change things without getting people to agree. So that makes them very secure, decentralized. You can get consensus with a blockchain, and therefore they're suitable potentially for recording of events, medical records, and so on. Anything which requires transactions. And there's this amazing Japanese, Satoshi Nakamoto, who it's not quite clear whether he exists. And it was invented in 2008 and implemented in 2009 as part of Bitcoin. And it's a ledger for recording transactions involving Bitcoin. And so blockchain for Bitcoin made it Bitcoin the first currency to solve the double spending problem, which actually I never heard of until making these notes. And double spending is the flaw in a digital cash scheme, because you can copy files. And so if you have a wonderfully secure record of a digital cash, you can just copy it, and that's double spent. So that's pretty serious. Okay, so it saves time because it's a totally digital approach. So we don't take days to verify things. It's instantaneous. There's fewer overheads because it's so clean. It's pretty tamper-proof, and it's more trustworthy. That's if it all gets implemented correctly. And here's the collaboration involved in blockchain. So there's a lot of people involved in blockchain. Here we have August 27, 2017. IBM forges blockchain collaboration with Nestle's and Walmart for global food safety. That's for tracking. So there's an example of it's nothing else to do with money. We want to know how the food is processed, so we can make certain that no steps are missed out. And if there's a problem, we can go back and find out what happened. So these are all examples of where blockchains are needed. So if you look at emerging areas and why they're using blockchain, this is 2016. The reasons vary from launching startups, cost efficiency, trying to understand what on earth this all means, worried about being disrupted by blockchains invading us, competitive pressure, all your friends are using blockchains, and being afraid of the financial technology industry. That's what fintech is. Very, very actual major activity is fintech. Okay, if you look at banking, then we want to use it for money transfers, especially international, where the trust is more important. Clearing, just recording the settlements of stocks and things like that. Well, this is anti-money laundering, AML, and know your customer. Well, I haven't heard of those abbreviations. A fiat currency is one that you believe in the government. Probably the dollar. Well, it says that the dollar is a fiat currency. Maybe it isn't any longer. We want to be transparent. I mean, the advantage of this technology is it's secure, but it's also transparent. It's decentralized. There's no centralized server which has to stay up the whole time and might get taken over by a monster. It actually is not so easy, it seems, to defraud. That you'd have to do a detailed analysis of that. Um, and just as a registry of, like food provenance, that's an obvious application. And then basically allowing one to do business as issuing securities. So these are all solid uses of it, and that's this list of applications, the end of this particular section. So blockchain is not quite proven, but if you look back on an earlier slide, Gartner has a prediction for its success, and it thinks it will succeed, but it will go through a quad page phase and then burst out later on because it will just take a while to build reliable infrastructure, reliable technology infrastructure. Thank you very much.